second lecture for week 2, and this is basically an introduction to C++. So before we actually start with C++, this is what we've been trying to do. We are trying to actually uh, get a journey from C to C++. So let us just go back to C for a short while. So what can you really infer from this particular C code, right? So something that you can figure out is probably that there are two methods related to addition, the add and add to result method. That these things you can probably see, and these it looks like that these two methods, add and add to result, may have been declared in the header file add.h. Okay, this is just, we are just trying to infer something from the code here. And similarly, there are two methods, multiply and multiply with result here, and it might seem like that these two are coming from the header file multiply.h. This is where these guys are, add to the result, multiply with result. So this is like, we are just trying to infer what this code looks like, and these observations, by the way, are correct, right? So this looks good to execute. Okay, whatever we have done, it looks like it should execute. However, when you actually try to execute this code, there are some errors out there, right? And there is an error regarding multiple declarations for the identifier result. Now you realize that in the code that I showed you, there is really no variable called result here, right? So where exactly is that result coming from? Apparently, if you see, it actually tells you where it is coming from. There are two places, one in multiply.h and one in add.h, and in both these places there is a variable called result. While the one in multiply is of type long, the one in add.h is of type int, and this is what the compiler really is complaining about, that there are multiple declarations for the identifier result. Now you can actually see that this is a very possible scenario, that there are two header files and they might have been created uh, parallelly from each other, and it is quite possible that the developers of the two header files chose some identifier name which actually collides with each other. Remember that this if and def and all these things that we do, it can only make sure that this part of the code gets included in the code only once. Okay, it doesn't actually protect you from having two identifiers which are of exactly the same name. Okay, the only thing it protects is from having multiple having these four lines, for example, added multiple times, but these four lines will be added at least once, and therefore there can be a possible scenario where there is a clash between any two header files that you are planning to use, right? And this is quite common if let us say you are using two header files which are coming from two different sources. Now in C++, this problem has been resolved in some sense, right? The major issue with the C code is that these extern variables are accessible everywhere. We actually had a look at the extern keyword in the last semester and we realized that the extern keyword makes the scope of a particular variable across the whole code that is being compiled currently, right? So essentially it becomes accessible to all the all the files. The scope is beyond even the file in which it was declared, right? So it becomes accessible to everywhere. Now C++ introduced a mechanism to restrict even global variables to a relatively smaller space. Okay, so basically it says that even though it is global, let me create a name space. Okay, basically it says that even though it is accessible everywhere, but there is a container outside it, right? So essentially, if you want to access it, you have to first tell me that this is the container, and then this is the variables, these are the identifiers within this container which I want to use. Okay, so a namespace is a collection of C++ statements, declarations as well as definitions, and all identifiers within a namespace must be unique. So basically you have now created a smaller subspace of the global space, and you say now the uniqueness check has to be only within this smaller space. It is not required that this uniqueness is across multiple spaces, right? So if we go back to the problem that we had, assume that you have two different source files coming from two different developers or organizations. As long as they have two different namespaces, you are pretty much guaranteed that there is going to be no clashes. That is the overall idea. And these namespaces can be hierarchical in nature, so you can have one namespace as a child of another, right? Not just this hierarchy can go to multiple levels. So within the outer namespace you can have two in different inner namespaces, so on and so forth. But usually we do not actually do this. Usually we try to have like one namespace, and in that we define all our code, right? So this and these namespaces can also be split across multiple files, that so basically within the same file you can have some code which belongs to namespace A, then you can just close that block. The namespaces are nothing more than blocks, right? Code blocks. And then you can start another namespace block and say, okay, this is going in another namespace block, so on and so forth. So it is possible for you to break these namespace spaces into at multiple locations, but that is usually going to be confusing. And so for now you should use namespaces pretty much like a global block. Okay, so whatever you define within that global block, that gets attached to that particular namespace. So this is at least in the beginning, you should only treat namespaces as nothing more than an additional block, an additional code block, and whatever is there in the within this code block, it needs to be unique, but outside the code block there can be duplicates. And in order to access a particular variable or a function that is defined within a namespace, all you have to do is use this scope resolution operator. These are basically two colons. Okay, so if you want to access a particular variable or a particular function, you just put the name of the namespace, then this scope resolution operator, and then the variable. So now the same problem that we had, let us try to resolve that using namespaces. So now I have just done this. These things are exactly the same. It's just that I have added this inside the namespace add ns, and I have added this inside the namespace multiple ns. So you can basically see that this adding code to a namespace is really not much different from the code blocks that we have been creating for so long, right? So these are just another code blocks, and now all I say is this result belongs to this code block, and this result belongs to this code block. And when I'm going to use it, now I need to know these namespaces. That is the idea. And you can see that now what I have done is that I have added the namespace and then the scope resolution operator, and then I have to call these methods. So this is the difference now in C++, that here you need to tell me the namespace in which this particular function was defined, and then there are no problems. You can see that now if I try to execute this code, it all works well. Yeah, I just added this joke. I thought we'll have this lecture as a live lecture, but you all know what is going on right now, so we have to I have to record this and then send it to you. So anyhow, some more C++ basics. Most header files in C++ do not have that .h extension that we used to see in C. So instead of writing something like stdio.h, the equivalent for stdio, I'm just calling equivalent. It's probably not the right term, but in the beginning you can just consider it to be the equivalent of stdio is iostream, and keep this in mind. It is just iostream, not iostream.h. There are some implementations, if I'm not wrong, implementations like Turbo C++, where I guess you have to add .h, but in most implementation this .h I guess is not required, so you just have to put iostream. The printf method, you all know, is used for outputting stuff, the equivalent in C++ is cout. It is not really a method but a stream, right? We'll get to know what streams are later, but essentially it performs the same task as printf. In fact, you might actually find printf to be a little more easy to use as compared to printf, because you don't have to give all those format specifiers, %d and all that stuff. Similarly, the scanf equivalent in C++ is cin, and cin2 is a stream and not a function. It's not too different as of now for you. There is an operator that you'll have to use, and these are the operators called insertion and extraction operators. And basically, in order to concatenate some elements to the output, you need to use the insertion operator. And if you want to take inputs of into multiple variables, you can do that in scanf, of course, but with format specifiers. You'll have to use the extraction operator with cin. So this is actually it looks much more simpler, to be honest, as compared to printf. This is an example, the cout and these insertion operators, and then you just put whatever you want to do, whatever you want to output. Then you can put another one here. Endel, by the way, is another way of putting /n. And here you can see that I have used another statement at the top. It says using namespace std. So why do we do that? So basically all the functions of the C++ standard library, they've been added in a specific namespace called std. Okay, and this means that if you want to use any library function, you'll either have to do something like std : cout. Okay, that is also fine, but because we usually use these library functions a lot, one way to do that, one way to tell the compiler that whenever I use a particular variable or a particular a particular function, please consider the default to be this std. So this statement is just doing that from here onwards, whatever whatever functions, whatever identifiers you use, the compiler will basically try to check if they belong to std. If they do, then you don't need to put std out here, so it becomes kind of a default. um, yeah, so basically that is the using keyword pulls up all the declarations from that namespace, so you are not required to write the fully qualified names using the scope resolution operator. And this is why we wrote cout and not std : cout. If we don't put this line, we'll have to write std : cout. And when you are trying to execute these programs, well, it's very similar to C. In C you used to do gcc space the name of the C file. Here we are using g++ instead of gcc, and the default executable name is still the a.out, and then you can run it like this. There are two more data types that any beginner should know about in C++, especially if you are coming from the C background, and these are bool and string. Bool data type is basically a primitive data type added in C++. It is essentially Boolean in nature. So if you remember, if you had to use something to store a yes or no answer in C, you probably used a char or a short or an int, right? So and you said, okay, 0 means false and 1 means true, something like that. In C++, you already have a data type for it, bool. Bool can take two values, true and false. So you don't really need to use a char, for example, to store these kind of Boolean values. Another data type which is not really a primitive data type, it is actually a class, but it is often used as if it's a primitive data type, is string. Okay, and string are objects. Okay, however, because of something known as operator overloading, there are certain operations that you can do on these objects as if they are some kind of primitive data type, right? For example, you can use the plus operator over two objects of type string, and it will mean concatenate these two strings. Okay, and there are other things that you can do as well. So similar to C, you can treat a string object very much like a character array. So you can actually go and change any particular character in the string using the subscript notation. That is the idea. That is how we used to do in C, right? That it's a character array. If you want to change, let us say, change the character number 2, you basically do arr 2 and then you do whatever you want with it. So all these things you can do with string objects as well. So that is why I said that even though they are objects, you can often use them pretty much like a primitive data type. So the string class is defined in a header file called string, just like this, string no dot h, and all the declarations are within the namespace std, as I just said. So this is an example. An instance of string can be created simply like this. You just put whatever you want as a string in double quotes, and you can access particular characters in this string by using the subscript notation, as you can see here. And you can use the plus operator to concatenate two strings. So for example, if you concatenate s1 with s2, you get another string s3, which is basically a concatenation of these two strings. Okay. And the bool variables, they can store, as I said, one of the two values, true or false. False is represented by 0 and true is represented by 1. So basically, if you print the values of a boolean variable like b1 or b2, what gets printed is usually 0 or 1. um, Bool types can also be used to store results of conditions. So all those if conditions and any other kind of conditions that you guys have written, their results can be stored within bool variables, because the result has to be either true or false. So this is an example where I am saying s3 is double equal to, it's essentially an an equality operation, s1 plus s2. If this is true, then boolean b2 will become 1, otherwise it will become 0. And if you run this code, this is how it will look like. You can see that these it is actually printing zeros and ones instead of true and false. You can also print true as well as false for for 1 or 0. Just check out the homework. And in your homework, what I have asked you to do is basically just explore the string class at a little more depth, because this class is going to be very useful for you. And the bool variables, if you want to print true or false, there is essentially a manipulator called bool alpha. So just have a look at what bool alpha is and how to use it. Okay guys, thank you. Let us hope that we'll meet soon on in the online mode. Okay, thank you, bye.